All right, this is going to be lesson 2-7, and we are on piecewise derivatives. We are on standard F, girls. Standard F is what?
Basic derivatives.
Basic derivatives. We're going into advanced derivatives tomorrow. We only have two different standards in this unit, and it's basic derivatives and advanced derivatives. So thank you, Sophia. You got the standard right. We have the setup ready for our notes. Now we're going to do the knockdown. So piecewise continuity test. Again, everything here is review, and then my next slide is going to be brand new stuff that's added on our old stuff. So my question for you girls, is F continuous at x equals 2? What are the three things that you have to check?
Elliott approach from the right, from the left.
Yeah,
And
so the exact, you guys have the rule down, and I'm going to write it in the notes on the left-hand side too, because I would like something a little bit more clear than this. It's that the left, this is the left as x approaches c from the negative, equals point, equals right. And I don't know if you can see the handwriting, but this is the limit of f of x as x approaches c from the negative side, equals f of c equals a point, the height at that point, equals the limit of f of x as I approach that same c from the right. So the left equals the point equals the right. So those are the three things we have to check. Let's check it. Go ahead and write them down with me. So we have to check limit. Okay, how do I say left?
limit as it approaches the left.
As x approaches what?
Negatives. Well, C. Negative.
It's a number in this case.
2 from, and then there's a negative sign.
2 negative sign. And I have to write something up here too. Limit of,
2. X.
no, of the function, of f of x, exactly. All right, someone aside from Sophia, do the next one. This is equal to what?
Equal. 4x minus 1.
Equal to, say it again?
4x minus 1.
Not exactly. Oh, I'm just saying, I'm setting up, it wasn't clear, that's my bad. I'm trying to set up this form where the left equals the point equals the right. So now I want to do the point.
No. 2.
So how do I say, what is the notation for point in this case? I think you might have said it. Can you say it again?
F of 2.
F of 2. Was that Carly?
Yep.
All right.
Yeah. Why did you whisper?
And then finally, this is equal to what? What is the notation for taking the right limit?
And x approaches 2 from the plus sign.
So read it perfectly. The limit of this as this.
Oh, limit of f of x as x approaches 2 from the
X approaches 2 from the what?
positive.
From the positive side or from the right side. Both of those are fine. Perfect. All right, so now underneath here, so that was 1, this is 2, and this is 3. We checked all three of these things. So underneath here, let's write what they're equal to. So what is the limit as f of x approaches 2 from the negative side? What does that equal? Bless you.
7.
This is equal to 7. Hold on, I'll pause here because she got that really fast.
Yeah. Hold up. Oh wait, because it's top is left, bottom is right.
Yeah, so it's usually top is left,
So
bottom
you
is right.
You
Yeah.
set it equal to 2. X equals 2. 4x times, or 4 times 2 equals 8 minus 1 equals 7.
Yep.
Gotcha.
And I'll repeat that in the microphone in case it didn't pick you up. So you're plugging in this, what do we call this guy again? Suspect
The suspect
point?
point.
Yeah. Plug in that suspect point into here. 4 times 2 minus 1 is 7. All right, f of 2 is what? This needs to be equal to, what is f of 2? Someone? 6? How'd you get 6?
Because isn't it the equals to?
Are you talking about the second line?
Yeah.
Yeah, it is this case because this is where the equal to sign is. So someone else, aside from Sophia, plug in 2 and do the math aloud.
So 2 times 2 is, or 2 to the power of 2 is 4, plus 2 is 6.
Okay, 6, perfect. And that also needs to be equal to what?
The right.
6.
6. Carly has 6. How'd you get 6 so fast, Carly?
You do the same thing.
Yeah, it's the same equation, right?
Right.
Yeah, so we
how
got
do
6.
you know f of 2 is the same as the right side?
Say that again, Carly, because that's the answer to her question.
You just plug in the same thing.
But why?
So this right here, this is saying I'm going to do this function if this happens. If x is equal to 2, that's where the bottom equal sign comes in. If it's equal to 2, I'm doing this. If it's greater than 2, if I'm greater than 2 from the positive side, then I'm also going to do this. So I end up using this equation twice, once at the point and once when I'm right of the point.
Yeah. Yeah.
All right, so are all three of these things equal?
No.
Okay, Isabel has it. No. Therefore, what conclusion do you have, Isabel, to this question?
F is not continuous at x equals 2.
Oh man, you phrased that so well. Can you say it again? I'll write down exactly what you write.
F is not continuous at x
You better quote her on
equals
that.
2.
I'm her lawyer, and if you don't give her copyright,
At x equals 2. Word for word what you said, right? I don't think I can improve on that anyway. Thank you.
But
well,
you didn't
put-
say
you didn't do
by
quotes
Isabel.
like Isabel.
You can do that in your own notes.
No,
For my
she
notes,
should know that's bad. You're copywriting. She could sue.
I'm not copywriting. What?
She's copywriting.
She never filed for copyright
I
claims.
said she filed for copyright.
I didn't see it.
I did.
All right, so you might want to make a note over here on the side that all three of these have to be equal. So all three have to be. My pen is messing up again. All right. So far all of this is reviewed. Do we have questions on this before I move on to our new stuff?
Do we have to do new stuff?
Yes, we have to do new stuff.
We're getting pretty good at this one.
All right, here we go. 3, 2, 1, next slide. Okay, this next title is going to be called Piecewise Differentiability Test. So, piecewise differentiability test. All right, so, and I'm going to switch back to a slide to show you how this is going to be similar. So similar to how I did a rule underneath here for the piecewise continuity test, I'm going to do a rule for the piecewise differentiability test. And here's the rule. See if you can squeeze it in on your left-hand bar. And if it overflows into the right, that's a little bit fine. That's okay. So I want to do the limit of f prime of c as x approaches that c, or sorry, not f prime of c, it's f prime of x. I apologize. F prime of x.
It's okay.
Everyone makes mistakes.
Everybody makes mistakes. Everybody has mistakes.
X approaches c from the negative side is equal to, what do you think I'm going to write here? Someone tell me what to write here.
F of x.
Close.
F prime of x? F prime of
Even closer.
c?
F prime of c. Yep. You guys got closer and closer. And this is equal to, someone tell me what to write.
Limit
Limit
of
of,
F
F prime of
prime with X.
We're out of room though.
I am too. I went into this side.
Arrow. C
As
plus.
x goes to c from the positive side. All right. Thank
Can
you.
we write this somewhere?
Yeah, you can write it at the top here if you want. I'm trying to do it in the sidebar to conserve space because this is the last thing that we need to write. I'm basically writing just as much as I wrote for the last slide. And if you can fit it on one page, that would be beautiful. Beautiful. Can we make a note here also that this guy right here, that, okay, my arrow's pointing the wrong thing, but this f prime is slope.
F prime.
And you can maybe have an arrow coming over here. I should have made that into a question for you guys, but I guess you guys wiggled out of it this time. So let's look at that same equation. So I'm going to look at this same guy. So I'm going to rewrite him. And give yourself about, kind of divide it halfway. So you do piecewise over here, and then we're going to do something else on the right over here. So I'm going to say f of x is equal to my piecewise function, 4x minus 1, and that's if x is less than 2, and x squared plus 2 if x is greater than or equal to 2. This this is going to be turned into something. So our question for this piecewise, the same piecewise function, is this. Is f differentiable at x equals 2? And there's our question. All right, so how am I going to check my f primes? What do I have to do with my piecewise function? What are you thinking, girls?
Wait, can you ask a question?
So remember that these are the three things that I have to check. I'm not checking f of x, I'm checking f prime of x as x approaches c from the negative side. I'm checking f prime of c, I'm checking f prime of x. So how can we change this f of x to make it more of this form?
F prime of x? Derivative?
Yeah, take the derivative. How do I take a derivative of a piecewise function?
Dinner doubter. I guess.
I mean,
Individually?
you're right, because you are doing dinner and doubter, but the way that you do it is, as Joy said, you take it individually, one at a time. So I'm going to rewrite this as f prime of x is equal to another piecewise function, and then I need to take the derivative of this top function. What's the derivative of 4x minus 1? Shout it out. 4, and that's if x is less than 2. It still has the same condition. X is less than 2. All right, someone aside from Joy, shout it out. What's the derivative of x squared plus 2? 2x. And what is my condition over here? X is greater than or equal to 2. Perfect. All right, so there's my question. Is f differentiable at x equals 2? What do we have to check? Let's write them all down. There's 3 things. Just like there are 3 things in the last slide, there's 3 things in this slide.
Right.
Oh my gosh. I blame my pen again. 1, 2,
You should give good old writing lessons.
3. Yeah.
Can you hand me a tissue, please?
Yeah, of course. Of course not.
Okay, underneath number 1, I'm checking what? Limit? Rewrite the rest of it.
Wait 1 second.
Limit of, you do the of first. Limit of,
Oh,
F of x. Or f prime of x.
and then Joy, you said S, close. It's not C.
oh, 2.
2 from the negative side, yeah. All right, this needs to be set equal to someone aside from Joy. Shout it out.
F prime of 2.
F prime of 2. Someone aside from Joy and Sophia.
Limit of f prime of x. X
As
as
Approaches
2 from the positive side. Perfect, yeah. We're getting better and better at saying this. All right, now we need to find what these are. So what is the limit of f prime of x as x approaches 2 from the negative side?
So you would plug in 2?
Yeah, so you plug in 2 into x.
4.
But there's no x, so it's
Well, it's 0x, right?
Oh.
So yes, you have it right. It's 4.
yeah.
All right.
X doesn't just disappear.
Okay.
I mean, it kind of does. It depends on your interpretation.
That's kind of.
F prime of 2. What is that?
4. Plug it into the 2 and
4.
4. How'd you get that? Kaylin, can you repeat what you said?
It's differentiable.
2 times 2.
Yes. Oh, oops, sorry.
Yeah, you're plugging it into...
People interrupt me. I'm really sorry.
What are you plugging it into, Kaylin?
The bottom one.
Yeah, the bottom equation for f prime. So 2 times 2, plugging in this. What do we call these guys again?
Suspect points.
Suspect points. Yeah, the suspect point gets plugged in. 2 times 2 is 4. And that's equal to
4.
4, because it's the same trick.
It's differentiable.
It is differentiable at x equals 2.
It is, yeah.
I thought you were going to hit me. I was like,
So, Isabel, do you want to do our perfect sentence again?
f is differentiable
Quote her.
at x equals 2.
If you're gonna write everything she says word for word, it's her quote. No one said that before.
F is x. F is differentiable at x equals 2. All right, so our steps for differentiability, and I'm going to go back here at the sidebar, and then I'll let you guys do the summary. So just making sure that we have the procedure down. So all this is under differentiability. I could write the word differentiability again. So number one, what did we do? The first step.
We take the f prime of everything.
So yes, I'm going to call that the second step, but you're right. You're going to take the derivative of each piece. I'm going to say, how do we even know it's piecewise differentiability test? What are we looking for? And the answer here is, it's talking about f prime. Differentiability means f prime.
You know it's okay. No, it's
So when you hear the word differentiable, can I just say diff, D-I-F-F, and you know that's differentiable?
Yeah. They might think it's
So differentiable, this implies that we need f, and I'm going to even spell it out, f prime. If you hear the word differentiability, always think you need to take the derivative, or f prime. And then the second step, as Sophia said, was you take the derivative of each piece.
Quarter.
Take derivative.
Oh my god.
I'm abbreviating in a ton to fit this
Can you
in.
spell derivative? I can't.
Yeah, derivative is derivative. Take derivative.
Anyway, I knew how.
All right, thank you. And then I guess a sub-step for step 2 is plug it in. Plug in suspect point. And final, step 3,
See if they're all equal.
I guess plug it in is step 3. I'm messing up here.
Ah,
I'm sorry.
We are on note paper. You could just move the arrow
Still
away
like
and then
to do
suddenly it's
pen.
number 3.
All right, just have step 3 pointing up here then. Step 3 is plug in.
Wait, it
I apologize. I was getting too far ahead of myself.
Hey, so it's okay. Sorry.
But to make my notes look pretty, I'm going to go ahead and erase and
Are you calling them ugly? You know, everyone's beautiful.
inside.
And out.
I don't know about out, but
Oh my god, Mr. Sindel, everyone is beautiful inside and out.
okay.
Why are you so judgmental about it?
Everybody is beautiful inside and out. I
Thank
agree,
you.
Sophia.
Thank you.
It's on video as well, so if you ever do that again.
no, but before it's on video that you're like, I don't know about out.
You're gonna delete it.
Yeah, you're gonna.
Yeah, I'll cut that part out.
Yeah.
All right, so before we end the video, before we end the notes, are there any questions?
Wait, so then 4 do we
Four
like
is
check?
like check they're all equal.
Sure. Let's make that
No,
4.
It's what we have to do.
Check all equal.
Did you hear that?
No.
Because I saw it.
I heard that.
I thought it was you like mumbling or something.
All right, now are there any more questions? Do we have everything? We understand how piecewise differentiability test works?
Yeah.
Yes.
For
Let's
summaries?
Yes, let's go ahead and do the summaries. Thank you for watching. Say goodbye, everyone.
Bye.